Hello everyone, I'm Sreja Rudra, Assistant Professor, Department of CSC, MLR Institute of Technology. Now I'd like to discuss a topic from uh, cryptography and information security regarding classical encryption techniques. You can see here symmetric encryption. Along with this, you're having an asymmetric encryption also. But let's see what is asymmetric encryption in detail. A conventional, private, or a single key. In this symmetric encryption, it is very clear that it will be having only a single key, and that is a private key. And sender and recipients share a common key. All classical encryption algorithms are private keys. This was only typed prior to invent a public key in 1970s by far most widely it's used. This is the some basic terminology. So plain text. Plain text means the general message or original message. So it is not having any coded words or encrypted words. It's just normal message called as a plain text. Next, ciphertext. So when we try to send a message from source to destination, we convert this plain text or the original message to ciphertext or the coded message. So cipher. For converting this plain text to ciphertext, we need some algorithms. That algorithm is a cipher algorithm, which is used for transforming the plain text to ciphertext. So cipher means it's the algorithm for transforming plain text to the ciphertext. The next basic word is key. Key means the information used in cipher known only to sender and the receiver. Here, this key information is known only to the sender and the receiver. And one more word is like encipher or encrypt. The encipher is at the source end, at the sender end, like converting the plain text to the ciphertext at the sender end. We'll say this encipher or encrypt. Then similar to that, we're having one more basic word, decipher or decrypt, recovering the ciphertext from plain text. Yes, it's just recovering the ciphertext from the plain text. Encipher is just converting the plain text to the ciphertext, and decipher is recovering the ciphertext from the plain text. Cryptography. It's a study of encryption principles and methods. Cryptanalysis means code breaking, like study of principles, methods of deciphering ciphertext without knowing the key. Cryptology, the field of both cryptography and cryptanalysis is called as a cryptology. So here you're having in a diagrammatic representation, you can see here an input in the plain text and in the output in the plain text. But in between, this plain text is converted to ciphertext by using the encryption algorithm called DES, and that ciphertext is transferred through the internet medium, and again by using some secret key, which is a shared key by the sender and the recipient, and decryption algorithm is used for the reverse of the encryption algorithm, and finally you get a plain text of that particular ciphertext. Here in this plain text, this is encrypted by using some secret key shared by the sender and the recipient, DES algorithm, and transmitted the ciphertext. Again, the ciphertext is not understandable by the user at the receiver. So again, it is converted to the plain text with the help of decryption algorithm. That also done by secret key shared by sender and recipient, and we get a plain text. Here important thing is, in a symmetric cipher model, you will have only a single key, and that is shared by both the sender as well as the receiver. If it is K, both the sender and receiver will share the key called K. In asymmetric cipher, you'll have a keys called K1 and K2. One is a public key, other is a private key. But here it's not like that. Next, what are the two requirements for secure use of symmetric encryption is a strong encryption algorithm, a secret key known only to sender and receiver. In this diagram, you had known that you must have a strong encryption algorithm and also a secret key which is known only to sender and receiver. Then mathematically, it's like y is equal to encryption key of x and x is equal to decryption key of y. We assume encryption algorithm is known implies a secure channel to distribute the key. Next, cryptography. Characterize cryptographic system by type of encryption operations used. See, and what are the type of encryption operations used? Substitution, transposition, product. Again, these three. Then again, we can characterize the cryptographic system by number of keys used. And again, we can characterize the cryptographic system by the way in which the plain text is processed. I mean, in a way of block or in a string. And the number of keys means whether a single key or private key or two key or public key. These things comes into consideration. Next, cryptanalysis, objective to recover key, not just messes. General approaches you're having is cryptanalytic attack and brute force attack. Now let's see what is this cryptanalytic attack and brute force attack. Cryptanalytic attacks means ciphertext only or known plain text, chosen plain text, chosen ciphertext, and chosen text. These are all similar words that we know. We can see everything in detail. Ciphertext only means only known algorithm, and ciphertext is statistical or it can identify plain text. Known plain text means no suspect plain text and ciphertext. Next, chosen plain text means select the plain text and obtain the ciphertext. Chosen plain text means we are selecting the plain text and we are obtaining the ciphertext. Chosen ciphertext means we are selecting the ciphertext and obtaining the plain text. Chosen text means we select the plain text or the ciphertext to encrypt or decrypt. Few more definitions are unconditional security and computational security. What is this unconditional security? No matter how much computer power or time is available, the cipher cannot be broken since the ciphertext provides insufficient information to uniquely determine the corresponding plain text. So, thing to be remembered is cipher cannot be broken since the ciphertext provides insufficient information to uniquely determine the corresponding plain text, and given limited computational resources, example time needed for calculations is greater than the age of the universe, and then here also the cipher cannot be broken. The second approach is brute force search. So always possible to simply try every key. Here what the attacker does is he will always try all the possible things he will have for the number of times. If that it is a 2 power 32, he'll be calculating and all that number of alternative keys he will try to use and break the code. Most of the basic attack is proportional to the key size. Assume either now or recognize the plain text. Here you can see if the key size is 32, then 2 power 32 is 4.3 into 10 power a number of alternative keys is having only for the key bit size 32, and the time required at decryption is 2 power 31 is equal to 35.8 minutes. This is just an idea to know how the attacker is having the time, and also time required at 10 power decryption. This is the tabular where for a size of bits, how many number of alternative keys the attacker is going to have. Thank you guys. Hope you understood well about this brute force attack and cryptanalysis attack. If any doubts, please ask me in the comment box. Thank you.